welcome to Class Connect study series with Yusuf Arkirio. In our last class, we examined instantaneous velocity, and we defined instantaneous velocity as the velocity of a body at a particular instance of time. We were able to observe that for a body not moving uniformly, the velocity with which the body moves will vary with respect to time, and for each time it varies, we can get the particular velocity that it's associated with that time, and that is what we refer to as instantaneous velocity. In today's lecture, we shall consider instantaneous acceleration. Instantaneous acceleration defines the acceleration of a body at a particular instance of time. For example, a body that is not moving with uniform speed of velocity is meant to accelerate. For every time interval, there is always an associated acceleration, and the associated acceleration is what is referred to as instantaneous acceleration. Instantaneous acceleration is usually obtained by differentiating the expression for velocity with respect to time, or by taking the second order differential of the expression for displacement with respect to time, and thereafter substituting the time implied in the expression obtained. We shall understand this by going through some examples, as we shall see very soon. Instantaneous acceleration, let's note that as A, can be written as the change in velocity with respect to time. That is, we obtain the derivative of velocity, and whatever we get will give us the expression for the instantaneous acceleration. If we are to obtain the instantaneous acceleration at a particular time, then we simply substitute the time t, let's say 2 seconds, in the derivative we obtained in dv dt. We shall follow up with some related examples. Let's consider this question. The velocity v of a particle in a time t is given by v equals 3t plus 2t squared. Find the instantaneous acceleration after 5 seconds. In this particular example, we have been given the expression for the instantaneous velocity, and we are told to obtain the instantaneous acceleration. All we need to do is to obtain the derivative of the instantaneous velocity, and from the derivative of the instantaneous velocity we can obtain the expression for instantaneous acceleration, and thereafter obtain the instantaneous acceleration after 5 seconds. In this particular question, you have been given the expression for the instantaneous velocity as v equals 3t plus 2t squared, and we are told to obtain the instantaneous acceleration after 5 seconds, that is t equals 5 seconds. So we obtain the expression for the instantaneous acceleration, that is dv dt, by differentiating v with respect to t, that is d dt of 3t plus 2t squared. And of course, we shall have 3 plus 4t. Now, since t was given from the question as 5 seconds, if we substitute in the derivative of v, we shall have that instantaneous acceleration a equals 3 plus 4 times 5, which of course will be 3 plus 20. And of course that means our instantaneous acceleration will be 23 meters per second squared. Lastly, let's consider this question. The motion of a particle is defined by the equation y equals 2t raised to power 4 minus 3t raised to power 3. Find 1. The velocity, 2. The acceleration after 3 seconds. In this particular question, we have been given the expression for the displacement of the body, that is y equals 2t raised to power 4 minus 3t raised to power 3, with y representing the displacement or distance of the body. Now, to obtain the instantaneous velocity as well as the instantaneous acceleration, we shall apply differential calculus as we did earlier. From the question, we're given that this displacement y equals 2t raised to power 4 minus 3t raised to power 3. We are told to obtain the instantaneous velocity, the instantaneous acceleration at time t equals 3 seconds. We shall start with the instantaneous velocity, that is v. We already know that v equals the y dt, that is the change in displacement with respect to time. So that we have v equals d dt of 2t raised to power 4 minus 3t raised to power 3, which of course will give us 8t raised to power 3 minus 9t raised to power 2. At t equals 3 seconds, we shall have that the instantaneous velocity v equals 8 multiplied by 3 raised to power 3 minus 9 multiplied by 3 raised to power 2, which of course will give us 8 multiplied by 27 minus 9 multiplied by 9. 8 times 27 will give 216 minus 9 times 9, 81, which of course will give us 135 meter per second. And that is the expression for the instantaneous velocity. To obtain the instantaneous acceleration A, we shall make use of dv dt, or we could also make use of A equals the square y dt squared, that is the second order of the differential of the displacement. Already we know that v from our previous page or previous slide was 8t raised to power 3 minus 9t squared. So that our A, let's take this, our A will now be dv dt. And of course, A will be d dt of 8t raised to power 3 minus 9t squared. Let's take a fresh page. So that our acceleration will be 24t raised to power 2 minus 18t. At t equals 3 seconds, our acceleration A will be 24 multiplied by 3 raised to power 2 minus 18 times 3, which of course will be 24 times 9 minus 54. 24 times 9 will give 216 minus 54, which of course will give us 162 meter per second square as the instantaneous acceleration. Thanks so much for watching. Hope to see you in our next class. And please do not forget to subscribe and click on the notification button. Thank you.